section 11.5, we're going to be learning about polar coordinates. We're going to locate points in a polar coordinate system. We're going to convert between coordinates between rectangular and polar systems. And eventually we're going to create graphs of equations in polar coordinates. So I'm going to start by explaining what the polar coordinate system is. If you have a point O on a plane, and we see the point O here, it's the origin of the pole, it's called the origin or the pole. And see, and the horizontal ray extending to the right with the endpoint O is going to be called the polar axis. So what we have here in green then is the polar axis, and you can think of the polar axis as being, if you sort of think about your unit circle and where you have 0 as the angle, then that's going to be your polar axis. A point P on the plane is going to be your polar coordinates. Is the coordinate r theta here, and the theta coordinate may be either positive or negative, and that's going to depend on how it's measured, whether it's counterclockwise or clockwise. And what I'm going to show you really quick is sort of a comparison between polar coordinate and the xy coordinate plane. So when we have a point in the xy coordinate plane, see, this is the point 2, 3 in the xy coordinate plane. What we have is that this distance here is going to be 2, that's your x coordinate, and this vertical distance here is going to be 3. When you're talking about a polar coordinate, what you're doing is you're not measuring that horizontal and vertical distance. Instead, what you're doing is you're measuring an angle, okay? So this theta right here is going to tell you the angle. So if we have a point P, it's going to tell you the angle to a line containing that point P, all right? That's going to be your theta. And then your r is going to be, sort of, if you think about what a radius of a circle would be, your r is going to be the length of that segment from what you would know as your origin. Right? So there's the difference between the two. Now here you see we have an example of some polar coordinates. So if I have this point 5 pi over 6, then you could see I could extend an angle, or I could extend this, and if you count the length of that, you're going to see that it's 5 units there, using the circular grid that you have. And then this angle here would measure pi over 6. And here we know that's the angle pi over 2. And if you count, that's going to be 1, 2, 3, 4, 5 units from the origin. And then on this next example, you have the point 2 pi, so the angle here is pi. And again, if you count, you can see you get 1, 2 units from the origin. The next one, we have the angle 4 pi over 3 going here. So that's the angle, and you are 4 units from the origin. And then the final example you have there, you have the angle negative pi over 4. So moving this direction, that's the angle negative pi over 4, and you are 1, 2, 3 units from the origin. The polar coordinates of a point P are not unique. For example, I have several examples here. If you have pi over 3, 7 pi over 3, and negative 5 pi over 3, these are all coterminal angles, and so these coordinates that I have here all represent the same point. So if you think about on a grid here, or on a polar grid, or just if you think about the unit circle, something that you're familiar with, you've got pi over 3 in this first example. If you go pi over 3 and then you are 2 units from pi over 3, that would be what I'm talking about or explaining here. Now if you have the point, this should be two and 7 pi over 3. Now 7 pi over 3 is greater than 2 pi. So if we think about how much greater it is, if you can say 7 pi over 3 minus 2 pi, and you realize what's going to happen is you're going to go around the circle more than once. And how much more? Well, if you subtract 2 pi, you end up with pi over 3. So really, 7 pi over 3 is coterminal. Here you can see that it goes around with pi over 3. And then again, 2 units from the center. And so these two represent the same thing. Now let's talk about a negative angle. A negative angle as 5 pi over 3 here is going to be if we start here on our polar axis and we move counterclockwise, clockwise to get a negative angle, then that's negative 5 pi over 3, which is coterminal again with pi over 3. And then again, 2 units from the origin. And so we have 3 examples, and there are other examples as well that we'll get to in a few minutes. Now, here's some of the other examples. The r coordinate may also be positive or negative, which is going to give us some other ways to notice that these polar coordinates are not going to be unique. So here we have the polar axis, and I have the point 2 pi over 4. So that's going to be the angle pi over 4. And once I come up with that angle, this is my angle pi over 4, moving here. So if I want to plot the point 2 pi over 4, as I have done, then I would go towards the pi over 4 angle here, so 1, 2 units, and I would get this point. But if I am given the point negative 2 pi over 4, then once I create that angle, I'm going to go the opposite direction and come up with this point, and that gives me negative 2 pi over 4. And this is going to be coterminal with actually a positive value, which we'll see in just a second. All right, and here's another example. You have the angle 7 pi over 6. That's the angle 7 pi over 6. So the positive end of this is here in black, and the negative end is going to be in red. All right. And then let's move here to this next example. We have negative pi over 2. So negative pi over 2, here's my polar axis. Negative pi over 2 is going to go this direction. So the positive end of negative pi over 2 is here, whereas the negative end of pi over 2, negative pi over 2, is in red. Now we're going to talk about the coordinate conversion that you would have. Let's say, to help us understand this, that first of all we want to learn how to go from polar to rectangular. All right, so let's say we have polar coordinates, and if we have polar coordinates, then maybe I have a point here, r theta, and I could construct this. So what I'm talking about is just that point, okay? Just to help us, I'm going to construct this. And really what I'm talking about, the point r theta, is this point that I have here. That's my point r theta. Now what I want to do is take that r theta, and I want to come up with my xy coordinate, okay? So to do that, what I'm going to be measuring is I want to come up with this y component here, and that would be a right angle, and I would like to come up with this x component here. And what I'm given is, let's put what I'm given in blue. I'm given r and theta. So remember, I have actual numerical values for r and for theta. I want to find what's in green, my x and my y. So let's think about how I would find x. Well, you could certainly use trigonometry for this. So if I want to find x, I could write an equation. I want to write an equation to find x using r and theta. And since compared to my theta, my x is going to be my adjacent, my r is my hypotenuse, then I could use the cosine. So I know that the cosine theta is equal to my adjacent over my hypotenuse. And remember, I want to find x, so I can solve both sides, multiply both sides by r to solve for x, r cosine theta. So that's x. Can be written as r times the cosine of theta. And now let's find y. Y is the opposite, so I'm going to use the sine of theta is going to equal to the opposite over the hypotenuse. And then I can solve for y, and y is going to be r times the sine of theta. Okay, so once I have those written, now I know that my xy coordinate can be written as r cosine theta times r sine theta. So given r and theta, I can find my xy coordinates using that. And now let's talk about what if you're given the reverse. Let's say I have what's in green. I have numerical values for what's in green, and I want to find r and theta. So this time what we're going to be doing is going from xy to r theta. Okay, that means I want to solve for r and I want to solve for theta. So I'm given x and I'm given y, and I need to find r. Immediately I start thinking about, you've got that right triangle, these are all side links, so we could say that r squared is equal to x squared plus y squared. And that would mean that r is equal to the square root of x squared plus y squared. Okay, and then when we go to find theta, we have an angle, we have the opposite, we have the adjacent. So we could say that the tangent of theta is equal to y over x. And then theta would be the inverse tangent or arctan of y over x. Okay, so that means at this point r theta right here can be rewritten as root x squared plus y squared arctan of y over x. And that's where these rules come from. And that's going to help us do some conversions here. Okay, so here what we're going to do is determine whether the given coordinates represent the same point as 2, 4 pi over 3, with this being r and this being theta. Okay, so first of all, what I'm going to do is go find the 4 pi over 3. And 4 pi over 3 is here. Okay, that's 4 pi over 3. And I'm looking at the positive end of that, which I have here in green. The negative end of that would be if I were to go backwards on that, okay? But I'm looking at the positive end because I have positive coordinates. So 2 units from that, along that green line, would be 1, 2 units. So I'm talking about this point right here, okay? And now I want to find if each of these are going to be coterminal, or if they're going to represent the same point. So I've got the point 2 and then negative 2 pi over 3. So 2 pi over 3 is here. So negative 2 pi over 3 is going to be back here to this green line. Okay, so that's negative 2 pi over 3 here to here. And then I want to find the negative version of that. So I'm sorry, I want to find the positive on that. So I've got positive 2. So positive 2 is actually going to put me back in the same place. I noticed that I would get this point again. All right, so here I am. So the first one works. All right, now the second one, what we're looking for is the angle pi over 3. So let's go and find the angle pi over 3 would be here. So I'm talking about the angle along here. All right, and so that's the positive pi over 3 side when I'm talking about my r, but it says negative 2. So instead of working on that side, I'm actually going to go to the other side, which again puts me back at the same point. So here I am. That one works out fine. And now for the last one, I'm working with 10 pi over 3. Now 10 pi over 3, we should notice that that's greater than 2 pi. So if I subtract 2 pi from that, then I get 10 pi over 3 minus 2 pi, or 6 pi over 3, is going to end up giving me 4 pi over 3. All right, so that's going to be the same as this. Okay, so we go and we find 4 pi over 3, and 4 pi over 3 is here. Okay, so that angle is going to be here. All right, and then I want negative 2. So that's the positive end of it that I have in green. So the negative end is going to go back this direction, and I would get negative 2, and I would come up with that point right there. Okay, that's C, which you notice is not the same. So this one would not work. And again, examples of how these coordinates are not unique. All right, in this example, we're going to convert each point from polar coordinates to rectangular coordinates. So what we have is we have r theta, and we're going to convert to xy. All right, and remember to do that, what we need to do is use r cosine theta times r sine theta. That's our formula that we looked at earlier. So using that, then I can say 2 cosine pi over 4, 2 times the cosine of pi over 4, and then 2 times the sine of pi over 4. And this is going to give me the rectangular form for this, which would give me root 2. All right, and now let's do the next example using the same formula. So I'm going to have, this is r, this is theta, this one looks a little different. 3 times the cosine of 2, and then 3 times the sine of 2. And answer again, it's going to come out a little different this time. It's going to be approximately negative 1.25 and then 2.73. Right? In example 3, we're going to convert each point from rectangular coordinates back to the polar coordinate form. So we're going backwards this time. So what we need to remember is that we have xy coordinate, and we're taking that to r theta. And if that's the case, then our form is going to be the square root of x squared plus y squared. And then the y coordinate is going to be the arctangent of y over x. Okay, so for the first one, then that gives us square root of 1 squared plus root 3 squared. And then the arctangent of root 3 over 1. And now from what we know about the unit circle, then we can simplify this, and we would get 2, and then the arctangent root 3 over 1 is going to be pi over 3. Okay. And now for our second example, using the same formula here, I'm going to have the square root of 3 squared plus negative 3 squared, and then arctan of negative 3 over 3, which is just 1, which is going to give me square root 18. And then this could be, so when you get this, you're going to get 7 pi over 4. Or you could also come up with going, instead of moving clockwise, you could also think about moving counterclockwise for this, and that would give you, I'm sorry, this is going to be the counterclockwise version. We could also think about moving clockwise, and that would be the negative pi over 4. Okay, because what you have is that angle. If you think about your unit circle, it's going to be down here. So for the 7 pi over 4, we would have this happening. And then for the negative pi over 4, we would talk about this angle, which both arrive at the same spot. And that's why you could come up with, for any of these, you can come up, they're not unique, so you could come up with other coordinates that represent the same point. All right, and we have one last example. On this one, what we're going to do is we're just going to graph some simple ones. Later, we're going to do some more complex ones. So what we have is r equals 5. So this is actually going to be a graph. Let's just enlarge this a little bit. So if I'm graphing r equals 5, if you think of that, I sort of think of it like a radius of 5. So where's the radius of 5? So if I count out, let's say I just start on my polar axis and I count out 5 units. 1, 2, 3, 4, 5. I'm here. And if I go on each axis and count out 5 units, or anywhere around here, then I hopefully pretty quickly realize that what I get is actually just this. So anytime you have r equals some constant value, what you get is a circle. Okay, and that would be the graph of r equals 5. On the other hand, when you have the theta is equal to negative pi over 3, okay, so let's find pi over 3 is here. Okay, so we're making that positive movement. If I make that same movement in the clockwise fashion, then I'm here at 5 pi over 3. So where is that going to be? That's the positive and the negative version of that. What that's going to be is it's going to be this. So that's the positive and the negative, and these extend forever. So what I come up with there is a line. These are sort of the equivalents to our horizontal and vertical lines with our XY coordinate plane. Instead of having horizontal and vertical lines, we have either a circle or a line. Okay, so with r equals some constant, we're going to get a circle, and with theta equal to some value, we're going to get a line.